Okay. Ready to go on this stuff now. Well, the first thing we're going to do today is really going to be just a little tiny extension of what we just got through doing. So it's going to be quick and easy. We have worked on simplifying rational expressions, which, Anthony, remind me, when I simplify a rational expression, what's the procedure?
You factor out the numerator and denominator.
Yeah, factor the numerator and denominator completely, and then,
Simplify
but how? Simplify how?
by adding like terms.
No.
Or
You've got it factored completely. And maybe it looks like this. And then what do?
divide like terms.
Not terms,
Factors.
factors. Remember, terms are things that are added and subtracted. Factors are things that are multiplied. You can only use division to cancel multiplication. I really want to get that vocabulary going well. Yeah. So yeah, that's how we simplify rational expressions. Factor the numerator completely, factor the denominator completely, divide like factors. That's the same thing we did when multiplying rational expressions. Because we said we want to simplify it before you actually multiply them together. Otherwise they get big and gnarly, can't work with them. So the next logical extension is to divide rational expressions. So that's where we'll start today, is dividing rational expressions. Alright. Now, we'll put a little statement over here of what we're going to do. But before we do that, we're going to go back in time again. And let's see, Connor, what grade when you learned fractions?
First grade, second grade,
Really?
maybe.
Wow.
Third grade.
Okay. Earlier than I remember. Maybe they introduced it like, you know, you have 5 pieces of candy and you get 2 of them, so you have 2/5 of the candy perhaps. But when did you start adding and subtracting and multiplying and dividing fractions, you guess? Or maybe it was first grade, but I don't know.
Probably fourth grade.
That's what I was kind of thinking around there. So let's go back to 4th grade. What happens when you take something like 2/5 and divide that by, I don't know, 3/8? How do we do it? And we've not grabbed the calculator and used the ABC button. No. Go, Sam.
Alright, well, since dividing by another division is like subtracting a negative, therefore you would take the reciprocal of 3/8 and multiply it by 2/5.
Okay. That's absolutely right. The first little part confused me a little bit. I'm not sure about that analogy, but anyway. Yeah, you're going to take the numerator and multiply it by the reciprocal of the divisor. So you said take the reciprocal of 3/8 and multiply by 2/5. I always think of it as taking the numerator and multiply by the reciprocal of the divisor. So take that bottom fraction, flip it over, and it becomes multiplication. And then if we can, I guess if I made up a better example, we could simplify maybe, but there's nothing here that'll divide out, is there? 5 and 3 are prime numbers, and there's no factors of 5 and 3 up top, so it's just going to give me, what, 16/15? And we're done. If I could have, I would have divided some factors out. Maybe I should have made a better example. But, oh, wow, hey, that's going to be hard, isn't it? In one step, my division problem turns into a multiplication problem, just like yesterday. Just like last night. And that's as hard as it gets. So here we go. When dividing rational expressions, we multiply reciprocal of the divisor, which of course is the bottom fraction. We'll just put that. So you're going to multiply the top fraction by the reciprocal of the bottom fraction. Excuse me. So we might have something that looks like this. X over x squared minus 4 divided by x squared over x cubed minus 8. That's pretty complicated looking. But it's really no more than just what we had a minute ago, that 2/5 divided by 3/8 or whatever it was. It's just one fraction divided by another fraction. So in one quick step, we take this division problem and it becomes just like yesterday. Take the top fraction, multiply by the reciprocal of the divisor, so we flip the bottom one over, and boom, in one step, my division problem turns into exactly like yesterday. It's a multiplication problem. We do it the same way. So, with that in mind, can I divide that 8 by that 4? Connor says no. Why not, Connor? 8's divisible by 4. Why can't I do it?
They're terms, not factors.
Bingo. I cannot factor an 8 out of that numerator. I cannot factor a 4 out of that denominator. Therefore, if I can't factor it out, I can't divide it out, right? I say that over and over and over and over. How should I handle this, Tate?
You can make the x squared minus 4 a binomial conjugate, which would be x minus 2 and x plus 2. That's
Okay, I agree.
x would be on the numerator.
All right.
That would be times a binomial times a trinomial. So it'll be x minus 2 times x squared plus 2x plus 4 all over x squared. And you can get rid of like factors.
All right. Get rid of like factors. What might they be, Miss Emily?
You can factor out the x minus 2,
X minus 2 divided by x minus 2, okay?
and then you can factor 1x out of x squared.
Yep. This one factor of x here will divide one of the two factors of x down there, leaving you with another factor of x left behind. And then we just express our final answer, and tell me what to write, Evan.
On the top, x squared plus 2x plus 4 over x times the quantity of x plus 2.
You're lying to me. Yeah. That's not true. They're not equal right now. We're missing a bitty something. Evan, can I substitute 2 in here? Will it give me an answer if I put 2 in?
Oh. No.
Bet you will. 2 squared is 4, plus 2 times 2 is 4, plus 4, that's going to give me 12 up top, and 2 times 4 is going to give me 8 in the bottom. That works. I can put 2 in there.
It won't work for the original problem.
Yeah, it won't work over here, will it? Because if I put 2 in for x, I'm going to get 0 on the denominator, and that 0 is going to multiply everything else. That guy's undefined for 2, right?
Yes.
So what we got to do here?
But all real numbers, x not equal to 2.
Well, we can just list that one exclusion, x not equal to 2. Excuse me. Yeah, let's not forget that. the factor that got divided out that's no longer apparent has to be listed as an exclusion. Now, we factored a factor of x, we divided rather a factor of x out, but there's still one left over. I can still see that x can't be 0. I can still see that x can't be -2. But here, I wouldn't know that x couldn't be 2 unless I remember to list it from before. So that's how we know what to put in for the exclusion. I guess it's confused and overlooked historically, so I want to make sure to stress that for you. That's the nuts and bolts of dividing rational expressions. Now, we might see them stacked one over the other like this. We might see them in a different format. Let's give ourselves one more to look at. Suppose we have fractions written this way. We've got x squared plus 6x plus 8 divided by x squared minus 16. I'm going to take that fraction and divide it by x cubed minus 1 over x squared minus 5x plus 4. Now, really, this is just another way of writing the same type problem, isn't it? Instead of having one stacked above the other, like in the previous example, I just got them written side by side. But which one is my denominator? The left or the right? Right, yeah. That's the one that's doing the dividing, right? The left one is being divided by the right one. So which one am I going to flip or multiply by the reciprocal? Which one gets flipped? The left or the right? Yeah, the right. Okay. Now, as you get into these problems, I would think that, most of the time we want to save steps and not have to write a whole big bunch, right? So as you're flipping, go ahead and start factoring. But be careful that you make sure and because you get so caught up in the factoring and the thinking about factoring, sometimes you accidentally put them in the wrong numerator versus denominator. So just be careful. Top left, Mr. Landon, have you got that numerator over here factored already?
Is it X?
Well, what kind of factoring will it be of my 7 types?
The trinomial?
Trinomial, so it's going to factor as the product of what?
X plus 2 and X plus 4.
Yeah, okay. Trinomial factors the product of 2 binomials is what I was fishing for a second ago. Okay. Bottom left, Camila, the x squared minus 16.
X minus 4 plus, and x minus, plus 4.
Correct, because we have a difference of squares, factors as 2 binomial conjugates. And now I'm going to multiply by the reciprocal of my divisor. So that numerator, the x cubed minus 1, will factor, but it's going to go down the bottom, right? Michael, how's that going to factor? The x cubed minus 1.
X minus 1 times x squared plus x plus 1.
And what kind of factoring did you just do?
Difference of cubes.
Good. All right. And the denominator, x squared minus 5x plus 4, if it factors, it's going to go up in the numerator. And let's see. Emily, how's that going to factor?
quantity x minus 1 and the quantity x minus 4.
X minus 1, X minus 4, and what kind of factoring did you just do? Trinomial factor, okay. Tate, is it factor completely? Any of those
Do that
factors
X
factor
squared?
further? Pardon?
The x squared can make like x plus 1, x plus 1?
Here?
No, you can't, never mind.
Why not?
Saying the middle be 2x.
So you're saying if I could go X plus 1 times X plus 1, all right, I like the fact that you have kind of checked yourself. Yeah, because outer products would be X, inner products would be X, and I'd give you a 2X in the middle. That doesn't work, does it? All right, and remember we said that the trinomial you get from a difference of cubes never factors further. And it's just an example right there, it doesn't do it, does it? Won't factor. But always look to ask yourself if you've got it factored completely. As I was looking at tests already from the factoring thing, some of you did some great work and stopped and could have gone more. So and that's why we want to say, oh, what type is it? How does it factor to know whether I can even try to go further or not? All right, we got all this stuff, and Mr. JT, what's going to divide out?
The x plus 4s,
X plus 4s are gone.
and then the x minus 4s,
X minus 4s are gone.
and the x minus 1.
X minus 1s are gone. That it?
Yeah.
All right. And now, just what's left over. All right. Anthony, tell me what you write.
X plus 2 over x squared plus x plus 1.
You're lying to me again.
Or x cannot be 4 or 1 or -4.
Good. Well done. Absolutely. Those three factors got divided out. They're no longer apparent in the final expression, so we have to list their exclusions. All right, very, very good. Hey, how would we decide what the domain of this guy is? Because I've got these three exclusions that got factored out. What about that denominator there? How could we decide if that thing, what x would make that guy be 0? Connor?
Quadratic formula.
Right. Yeah. We have to say, set that quadratic equal to 0, then maybe try quadratic formula and see what we got. All right. That we may be a little rusty on. We'll hit that again later. All right, that's dividing rational expressions. Just multiply by the reciprocal and boom, it turns into a multiplication problem just like last night. That shouldn't be a big extension. Any questions on anything we got up here before I erase? All right. Now again, you know, just to maybe help, as you guys are taking notes, you know, I'm up here saying a lot of stuff, but I don't necessarily write everything I say. You're probably writing everything that I write, but if you need to, if I do something, you go, oh, that's why I did that. You know, if there's something that says, oh, that's why he put those out here, then put yourself a little note, a little thought bubble out there, and say he has to list these exclusions because you're no longer apparent from the factoring. Or these are listed because these are what got divided out. If there's something that makes you go, oh, then make a note of it, because that's something you need to remember. That's just a little note-taking skill that I got for myself in college, and that helped me a lot. Because I'd forget, you know, down the road. But if I had a little reminder there of why we did what we did, it helped reinforce it for me. Okay. So we got dividing rational expressions. Now, well, let's see. We multiplied them, we simplified them, we multiplied them, and we divided them. What's left to do? Add them. Let's add and subtract rational expressions. I think we at least introduced this today. We won't get all the way through it. Adding and subtracting rational expressions. Alright, again, I'm going to put a little statement up here of what we're supposed to do, but let's back it up and go back to the basics and subtract fractions. Let's see if we can't come up with a nice example here of let's get 3/35 plus 5/18 minus 1/25. Whew. That's gonna be fun, isn't it? And no, you don't get to grab a calculator. We might need to here in a minute, but I don't want to just, we don't just want to grab a calculator and do it. We want to remember what's the logic in what I have to do. Yeah, can I just straight up add 3/15 to 5, or 3/35 to 5/18? Can I add them together? I have a couple of heads shaking no. Why not? Go Sam?
Because they don't have like denominators.
Yeah, they'll have common denominators. We can only add two fractions, like say 3/35 plus 6/35, if they've got the same denominator. If I've got 3 apples and I add it to 6 apples, I'm going to have 9 of those. That's not quite the right analogy, but works. Okay. If I got 3/35 of a pizza and I add it to 6/35 of a pizza, if I got a pizza sliced into 35 pieces, I mean some skinny slices, or a big pizza, and I got 3 slices, and then I get 6 more slices, and I've got a total of 9 of those 35 slices. Yeah. So I can do that. You add the numerators, keep the same common denominator. But I gotta get common denominators first, don't I? Remember that from 4th or 5th grade or whatever. Alright. Now, if I were to have given you a nice little problem like, 2/5 plus 3, well heck, how about 2/5 plus 1/2? Let's start super easy. What's the common denominator that I'm going to need? What's the least common denominator? Okay, 10. Yeah, so I threw it out there. It's 10. Alright. So, what would I have to do to make them have the same denominator? Go Sam?
Well, for the 2/5, you'd have to make them equal, so you'd multiply it by 1. However, the numerator would need to be multiplied by 2, and the bottom would be multiplied by 2.
Yeah. Multiply by 2 over 2, which as Sam said, that's just 1, right? So I'm not changing the value at all.
And for the 1/2, you would do a very similar thing where you'd have 5 over 5 multiplied, which would be 5/10.
Uh-huh. Okay, yeah. Basically, one way to do it is to take this denominator, multiply top and bottom over here. Take that denominator, multiply top and bottom over here. Now, because these were small and they were prime, then yeah, 10 is my least common denominator. It's going to be the smallest number that both 5 and 2 will divide into. That's the least common denominator. Okay, and that's pretty easy. It gives me 9/10, right? Okay, no biggie. But over there, 35 and 18 and 25. Now I can do what I just did. I can take the 35 here, I can multiply by 18 top and bottom and 25 top and bottom, and that'll work. I mean, I'm not going to finish this in this manner, but let me write this. I'm going to do it a different way. I could, if I so choose, take this 18, multiply it top and bottom. That's just multiplying by 1, right? That's legal. I can take that 25 and I can multiply it top and bottom. Oops. long as I'm right at 25. And that's legal. I could take the 35 and multiply top and bottom here. And I could take the 25 as well. And now here I'd have to take the 35 from over yonder. And I'd have to multiply the 18 as well. Okay, now they're all three gonna have the same denominator of whatever the heck 18 times 35 times 25 is. That's gonna be a great big number, isn't it? That will be a common denominator, but it won't be the least common denominator. That would work, but then whatever great big Mongo answer I got out here, I'd have to simplify that. So there's a more efficient way. Now, how in the world, now, it's pretty easy to see the least common denominator of 10 here, what? That pretty much came to everybody, I hope. But over there, boy, what's the smallest number that 35 and 18 and 25 will divide into? I don't know. Let's see. Hey, somebody do grab a calculator. What's 35 times 18 times 25?
1,019 over 31. 50.
I'm sorry, just 35 times 18 times 25. Just multiply those three numbers together. What's that?
1,507. I didn't say that right.
No.
25.
15,750. Okay, I thought you were giving me the numerator and denominator. All right, yeah, so that's going to be a common denominator. But if I made this upright, it won't be the least common denominator. How do we find that? And this is going to be the kicker for when we start getting these rational expressions with all the algebra. How do we find the least common denominator? Put this up here. Because we're going to want the least common denominator, because if I don't get the least, then I've got to factor and simplify my answer after I'm done. And with this math, arithmetic one, we can do it. But with algebra ones, they get really big and gnarly, that's a lot of trouble. So to find the least common denominator, we factor each denominator completely. And take one of each factor raised to its highest power. And I think I better stop because I've only got about a minute. I'm going to get an assignment for tomorrow. We'll have to continue this discussion tomorrow. So for tonight, let's see. Last night we did up through 27. We're going to be on page 48. We're going to get 28. Well, let's do 28 through 32. And then we picked up 38. Let's get 39 through 42. Ooh, I see some more I like. 53 to 55. We've been doing something like that. I like those. We'll get those. All right. That's our assignment for tomorrow. Or for Monday. Have a great weekend.